So I'm here to give an update on MaPPeRTrac, which was presented about 3 years ago at Parcel Fest by Robbie. Just a quick overview. We'll do a diffusion MRI and tractography primer, an overview of the software, and then updates since and our future directions. So diffusion-weighted imaging of the brain is one way to measure the structure and the structural connectivity between the regions of the brain. And so we're looking at how water moves around, and there's various things in the brain that can stop water from moving, and some of those matter more. And using that information, we can then reconstruct the different directions that the water would be moving, and build out our tracks to follow the various axonal connections between those regions. And this is an important part of clinical neuroscience and surgical planning for all sorts of things. But one of the big bottlenecks in this computationally is the tractography itself. So to get the structural connectome, which is a rich biomarker source for aging, MS, traumatic brain injury, there's quite a bit of computation involved. When I was first starting as a grad student, we had one workstation that we would start one job at a time on, and that could take 24 hours. So my PhD would have been finished 2 years from now if we stayed with that. So luckily, one thing that we've developed, and this is in submission now to Neuroinformatics Journal, is MaPPeRTrac. And so MaPPeRTrac takes the diffusion MRI, runs FreeSurfer, which is a surface reconstruction to get this high resolution anatomical labeling of the brain, and then Bedpost and ProbTrac X, which do the diffusion signal reconstruction and tractography. And we're able to get these edge density images out, which helps, as the source for any number of biomarkers and more complex downstream analysis. But the updates that we've done so far, updating the dependencies, there's different software toolkits people use for neuroscience and for neuroimaging processing. And so we wanted to have those in parsimonious containers so that folks can download them as they update and get the advantage of the newest community code coming out. And so I updated the CLI for MaPPeRTrac so that we could use these multiple containers and put out the recipes and build files. And some example usage for DataLad, which is one way to massively share data sets that's popular in the neuroimaging crowd. And then, a couple of things that are more inside baseball, but support our more modern data collection that we use for diffusion-weighted imaging. And enhancing the parallelization by running some of the tractography as separate instances for each edge chunk. So that's could be up to 100,000 edge chunks. So it's very, very good to be able to parallelize that out. And just some simple benchmarking. The part of this that takes the longest is that FreeSurfer surface reconstruction. But after that, we're able to speed up to about 3 minutes for the signal reconstruction, and for the edge density imaging, about 3 or 4 hours for that. But again, this is a pretty good speed up from where we were at about 5 years ago. So that's our benchmarks, our future directions. We look to incorporate some more of the pre-processing methods that are available, and to get the best quality out of our data. And accelerating out that FreeSurfer step by using neural network-based reconstruction for the surface with FastSurfer, and hopefully we'll be able to get to about maybe a couple hours per data set, which would be great. And that's about all that I have. I just want to acknowledge all of the various sources of funding for this project, and I should be ahead of time.
Yeah. So, questions from anyone?
But this replaces FreeSurfer
Uh,
or works on top of?
So Resurfer is incorporated as part of the process, but FastSurfer would replace Resurfer. So that's that faster neural network based. And that will work within probably most cases, unless you have like gross brain anatomy differences. There might be some failures there.